Hello friends, welcome again to my channel. In the last few videos we have seen about the waves, and now that is what the first unit. Now that was the end of that unit at the last article, that was equation of motion of a vibrating string. Now today in this video we will start our new unit or new topic, that is stationary waves. According to your syllabus it was unit number 2nd. Okay. So, unit 2nd is stationary waves. So, first of all we will see what is stationary wave. What we call the stationary wave? Does it different from the normal standing wave? Stationary wave is also called as the standing wave. So, let us see why it is also called as the standing wave, and does it different from the other type of waves. So, the stationary waves actually they forms with the combination of two waves. They forms with the combination of two waves, but those two waves are traveling in opposite directions, moving in opposite direction, but their phase as well as the frequency and amplitude are always same. Their phase, amplitude, frequency are same, but their directions are different. That means we can define the stationary wave as the combination of two waves moving in opposite directions is having the same amplitude and frequency. Again the phase is also same. The phenomena is the result of interference or the superimposed. We can call it as the interference. We know that interference in case of the light waves, it is a superposition of two or more waves. So, same we can call it as here it is superimposed, or one wave is superimposed on other wave, but they are moving in opposite direction, or we can call it as interference. Their energies are either added together or cancelled out. Okay, that is what the next thing means. Not necessarily always the resultant wave is enhanced in all respect. Sometimes the resultant wave is enhanced in one of the property, or the energy can added together, or sometimes the energy can get cancelled out. That means energy can be minimized or can be maximized, or we can say enhanced, or we can have the decrement in the energy, depends upon how they are superimposing on each other, or how they are meeting with each other, or how the two waves which are moving in opposite directions are getting combined with each other. So, simply the stationary wave or standing wave means combination of two waves having same amplitude and frequency, but traveling in opposite direction. So, when we say that two waves are having same frequency and amplitude and they are traveling in opposite direction, so how will be the energy distribution and how will be the displacement and all these things. So, depends upon that we have two different types of positions in that particular wave. One is called as node and another is called as the antinode. That means antinode is the position where displacement of the particle is maximum. Here you can see this point is antinode, 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 where now this red line, horizontal red line, is we can say the mean position. Horizontal red line is mean position, and from that mean position the antinode is having maximum displacement. Antinode is having maximum displacement, while this is node, where from where it is started. This is also a node, and here the node is at node the displacement of particle from the mean position is almost 0. It is 0. That means when all the particles of the medium are at the mean position, then that position we can call it as node. Here it is node, here it is node, but here this is what antinode. Antinode in top direction, antinode is in reverse direction also. And moreover we can see here also the combination of two wave, and here also the combination of two wave. Okay, now see, when we say the combination, so two waves forms and node and antinodes are forms. Now we got that what is node and what is antinode. Now moreover the complete wave, that means what, when we say about any two nodes or antinodes or this particular thing completely one cycle, it is denoted by, or it is nothing but the wavelength. It is called as the wavelength, right? So, how much is the length of one wave, that is called wavelength. So, we can say this as wavelength lambda, but if we talk about only up to this point, so this will be, or exactly half, that will be lambda by 2, and one more lambda by 4 is added, so that will be 3 lambda by 4. That is what we have denoted here. All the calculation part we will see in next slide, but for here just to you please understood what is node and what is antinode, and obviously the complete distance for one wave we call it as wavelength, that is what lambda. Just forget about this 3 lambda by 4 and all, we will see later on. Now what here these two diagrams are, because we have to do the analytical treatment for this stationary wave. Analytical treatment means, yes, we have to find what exactly happens to the node. Now here I am saying directly, yes, this is antinode and this is node, but no, how you can say directly? You can ask me the question, sir, how will you directly define this is node and this is antinode? So that's what we have to do in this next article, or the very first article from this unit. The analytical treatment of stationary wave means we have to calculate all the things so that we can say, yes, this is what the position of antinode, this is what the position of node, and how much will be the distance between them, and all these things. Because moreover, this wave or these nodes and antinodes are not only the depends upon position, sometimes, or other things are there, velocity is there, strain is there, depends on that. We have to say whether it is a node or antinode, and moreover some parameters are depends on time also, and so that means we have to see the changes with respect to position as well as changes with respect to time. So for while here, just take what from this slide, what is the definition of stationary wave, and yes, this is what we can consider the pipe open at both ends. So this is what black color cylindrical pipe, and which is open from these both ends. So this is a pipe open at both ends, this is what pipe open at one end. So these two types, or these two different cases we have to study in this analytical treatment. So if we move to the next slide, yes, you will find the statement, or will find the name of article, analytical treatment of stationary waves. So now again I have drawn here a diagram in which both the ends of pipe are open. So we can say the first case here, see, first case or the first particular pattern we have to look into forward, that open end organ pipe at the other end, means both the ends are open, or we can consider this as a string free at other end, string free at other end. That means the string also can generate stationary waves, but both the ends, let us consider, are open, or you can consider open end organ pipe. This is an organ pipe. It is like, we can say, an organ pipe which is open at both the ends, like our flute and all. Okay, so here when we talk about the stationary waves, so whether it is organ pipe or string, when we produce stationary waves within it, then yes, we will see that at the end of that organ pipe or at the end of the string, you will always find antinode, and at the center it is node. So as we have shown in the diagram, so we have just to consider one particular wave, and what happens to the end will always give you antinode, and at the center we will always find node. So let us find some calculated part, and then from that we will decide where the node is present, where the antinode is present, and all. We can say the position of node and antinode. So first case, open end organ pipe, or we can say the string open from both the ends. So let us consider the stationary waves are formed in organ pipe, open end organ pipe. Consider a simple harmonic wave given by the equation. So already we have seen this equation, y is equal to a sin 2 pi by lambda. This is what the general equation to represent the simple harmonic wave. So here, yes, when we talk about the one wave which is moving in this positive direction, one wave which is moving in positive x direction, so it can be written as generally y is equal to a sin 2 pi by lambda Vt minus x, but we have here two waves, that is why we will name it as y1. So y1 is an incident wave moving from this point to this side, that means positive x direction, that is y1 a sin 2 pi by lambda Vt minus x. It is called incident wave. For our convenience, we will call it is incident wave. And one wave is moving in this reverse direction. Okay, so that wave also denoted by similar formula, a sin 2 pi by lambda Vt minus of minus, because it is moving in negative x direction. It is moving in negative x direction, that is why minus of minus plus, because minus is in general formula, and minus of minus. Why minus x again? Because it is moving in negative x direction, and therefore this minus minus becomes plus, and a sin 2 pi by lambda Vt plus x, this is the equation for reflected wave. Name it as equation 1 and equation 2 for these two, incident wave and reflected wave equation. Now yes, we know the combination of these two wave will form the stationary wave. Therefore, we can say the resultant displacement of this wave. So, resultant displacement, simply add them together. So, if we add, we will get the resultant displacement, that is y is equal to y1 plus y2. Y is equal to y1 plus y2. y1 and y2 we can substitute from this equation 1 and 2, and we will get the equation number 3, a sin 2 pi by lambda Vt minus x plus a sin 2 pi by lambda Vt plus x. So, these two equations we have substituted in the resultant displacement y is equal to y1 plus y2, equation number 3. Now, from this equation number 3, here we have to use one formula, sin c plus sin d, because see here sin, because small a here we can take it common, but we have sin c plus sin d. Now, here c is 2 pi by lambda Vt minus x, and d is 2 pi by lambda Vt plus x. So, sin c plus sin d is 2 cos c minus d divided by 2 into sin c plus d divided by 2. Okay, do not worry, we will see this on whiteboard. Okay, right. So, what I am saying here is sin c plus sin d, this formula we have to use, and what is that formula? 2 cos c minus d divided by 2 into sin c plus d divided by 2. This is what the formula, mathematics people might have known this. Sin c plus sin d is equal to 2 cos c minus d divided by 2 into sin c plus d. And here what is our c? C is 2 pi by lambda Vt minus x, and what is d? 2 pi by lambda Vt plus x. So, simply substitute c value here, d value here, c value here, and d value here. So, again in that c and d 2 pi by lambda is common. So, one is, or c basically it is Vt minus x and d is Vt plus x, if we remove or if we take common 2 pi by lambda. Okay. So, once Vt minus x minus Vt plus x, so minus Vt minus minus or minus plus, it is minus. So, what happens? This Vt and this Vt will get cancelled, and this minus x and minus x becomes minus 2x, and hit whole divided by 2, because this is what the 2. So, 2 minus 2x divided by 2 means minus x, means cos of minus x, obviously 2 pi by lambda common. So, my cos of minus 2 pi x by lambda, but we know that cos is a even function, because or means cos of minus theta is always equal to plus cos theta. Cos is called as even function, and therefore, we can write what we will get from c minus d. Here we will get the term cos 2 pi x divided by lambda. This will be the term, and similarly if we do for the sine, so in that case sin 2 pi by lambda will be 2 pi by lambda will be constant, and from this Vt minus x plus Vt plus x, Vt minus x plus Vt plus x, in that plus x and minus x will get cancelled, Vt plus Vt will be 2 Vt and divided by 2 from that formula, that is why 2 get cancelled and it remains only Vt. So, finally, we will get 2 pi Vt by lambda. You please calculate according to that formula, and you will get this equation, equation number 4, y is equal to 2 from that formula, 2 cos c minus d divided by 2 into sin c minus c plus d divided by 2. So, from that we will get the resultant displacement y is equal to 2a cos 2 pi x by lambda into sin 2 pi Vt by lambda. This particular equation represents the equation for our stationary wave. Okay, y1 is not for stationary wave, y2 is not for stationary wave, y1 is for one wave which is moving in positive x direction, that's why we call it as incident wave. y2 is moving in negative direction, we call it as reflected wave. But now y is y1 plus y2, and by doing that mathematical calculation we found this equation number 4. So the resultant vibration of a particle represents a simple harmonic wave of the same time period. The amplitude of the resultant wave is given by, that means what, see, this is also in the form of our simple harmonic motion equation. Yes, what is simple harmonic motion equation? General, a into 2 pi by lambda Vt minus x. Yes, but a is their amplitude. Now look at this complete 2a cos 2 pi x by lambda is amplitude, and this particular thing will be the wave part. Remember always the part in equation which is except t, now this sign will be the t part, right? Except t part will always be a amplitude, and remaining t part is the wave part. So here the resultant wave or the stationary wave is having amplitude this much, 2a cos 2 pi x by lambda. Here instead of that we can write capital A, so we can rewrite our equation y is equal to capital A sin 2 pi Vt by lambda. That is what the displacement equation for stationary wave. Okay. Now the resultant amplitude is a function of x. Yes, clearly here from this we can say a is constant, cos and 2 pi by lambda is also constant. So the resultant amplitude is simply the function of x, right? Now once you got the resultant displacement, if we want to calculate the velocity of that wave, simply differentiate it with respect to time. Now these things are also common what we have done in previous lectures on previous videos also. Similarly, once you got the lambda y, that is displacement, now from that if you have to calculate the velocity, what you have to do, take its derivative, moreover take its time derivative and keeping x constant. So differentiating equation number 4 to get the velocity of a particle at any instant, that is dy by dt. So after differentiating, see equation number 4, dy by dt, left hand side dy by dt. Here 2a cos 2 pi x by lambda, everything is constant because we have to take the derivative with respect to time, and here is only one term which contains the time factor, that is 2 sin 2 pi Vt by lambda. So 2a cos 2 pi x by lambda is constant. Taking the derivative of sine with respect to time, it will be sine derivative is cos. Yes, it is as it is cos, we have written cos 2 pi Vt by lambda, but again we have to take the, by chain rule we have to take the derivative of this factor 2 pi Vt by lambda, and in that 2 pi V by lambda is constant and derivative of t with respect to 2 is 1. So constant factor we are getting by the chain rule is 2 pi V by lambda, and already we have 2a. So 2 into this 2, 4, therefore 4 pi a V by lambda cos 2 pi Vx by lambda, here it is as it is, and derivative of this sign is cos. So it is cos 2 pi Vt by lambda, equation number 6. Simply we have taken the time derivative of equation number 4, and that will give you the velocity of particle at any instant of time. Okay, that is equation number 6, right? Now to find the acceleration of the particle at any instant, yes, obviously the rate of change of velocity once again, that means we have to differentiate equation number 6 one more time. Equation 6 is now velocity. If we differentiate equation 6 one more time, that will give you the acceleration. So equation 6 left hand side is dy by dt, it's a double, it's a one more time derivative means d2y by dt square, that will give, that is what acceleration of particle at that time instant. Now right hand side, again here 4 pi a V by lambda, this is constant, 4 pi a V by lambda. Cos 2 pi x by lambda is also constant because we are taking derivative with respect to time. Okay, keep aside derivative of cos 2 pi Vt by lambda. Yes, this term contains time factor, that is why it is derivative. So the derivative of cosine is minus sine, so minus 2 pi Vt by lambda, minus sine 2 pi Vt by lambda, and again one more time by the chain rule, derivative of this inner theta, 2 pi Vt by lambda is theta. So from that we will get 2 pi V by lambda, derivative of t is 1 with respect to t. So 2 pi V by lambda, and with negative sign, and this cos becomes sine. So therefore, right, see from this inner theta we will get 2 pi V by lambda, and already here it is 4 pi a V by lambda. So 4 into 2, 8, pi into pi, pi square, a as it is, v into v, v square, in the denominator lambda into lambda, lambda square, and negative sign cos 2 pi x by lambda as it is, and derivative of cosine is sine. So, sine 2 pi vt by lambda. Look at this factor, how it is came. Yes, only because of the double derivative. Simple. And this is what the acceleration. Equation number 7 gives you the acceleration of particle. Right. Now, again, to find the strain or compression. Compression is also known as strain. So, when we talk about the waves are moving through the medium, the particle of the medium either have the compression or rarefaction. So, when we have to find the compression, simply we have to take the derivative of displacement with respect to position, that is with respect to x, keeping time constant. So, to find the compression or strain, let us differentiate equation number 4. Let us differentiate equation number 4. This is what the compression or strain, dy by dx. So, what is equation 4? Equation 4 is y, and if you want the dy by dx, let us differentiate this with respect to x. So, differentiating with respect to x means now here 2a is constant, and now this second term is constant because we are differentiating with respect to x. Therefore, this t factor term will be constant, sin 2 pi vt by lambda keep aside, and derivative of cos 2 pi x by lambda with respect to x. So, derivative of cos is minus sine. So, minus sine 2 pi x by lambda, and again this inner theta chain rule derivative, it is 2 pi by lambda. 2 pi by lambda, and already it was 2a constant, that is why 2 into 2 4. So, minus 4 pi a divided by lambda sin 2 pi x by lambda, and this sin 2 pi vt by lambda was a constant and it was kept as it is with respect to x. Okay. So, this equation number 8 will give us the compression or strain, right. Okay. Now, from the equation 5 to 8, let us see what we got. Equation number 5 is amplitude of the resultant wave. Equation number 6 is velocity of that particular wave particles or particle velocity. Equation number 7 is acceleration of the particle, and equation number 8 is the strain or compression. Okay. So, that is what we have written here in one statement. Equation 5 to 8 shows that the amplitude, velocity, acceleration and strain vary with the position and time. If we look at these all equations, equation number 5, yes, it is having position factor x, right. It does not have the time factor, but it is having position factor. And equation number 6, that is velocity, it have position as well as time factor. Again here in case of the acceleration, position as well as time. Here position as well as time. So, here we can say equation 5 to 8 all amplitude, velocity, acceleration and strain vary with either position or time or both. Now, it means that we have to see the changes with respect to position as well as changes with respect to time. Okay. So, these 4 equations we have to keep in mind, 5, 6, 7, 8. These 4 equations we have to see how they are changing. If we do little bit change in position, if we do little bit change in time, and from that we will decide the position of node and antinode. We will exactly find the distance between node and corresponding antinode. So, let us move towards the next slide. First subheading we can write the changes with respect to position. Here first what up to this what we understood, they are changing either with respect to position or time or both. So, let us see first of all changes with respect to position. Again all these 4 equations, equation from 5 to 8. So, changes with respect to position, we have to see the 2 different cases. So, first case, consider the position where sin 2 pi x by lambda is 0 and cos 2 pi x by lambda is equal to plus minus 1. Sin 2 pi x by lambda is 0 and cos 2 pi x by lambda equal to plus minus 1, because we know that sine and cosine maximum value is plus minus 1 and minimum value is 0. So, in one case, here we have written first case. So, in one case we will consider sine is minimum, cos is maximum, and in second case we will consider cos is minimum and sine is maximum. So, whichever we can take first, does not matter. So, we will first consider sine is minimum and cos is maximum. So, minimum value of sine or cosine is 0 and maximum value is plus minus 1. So, if we consider or if we apply these two things, now whatever we have considered, sin 2 pi x by lambda equal to 0 and cos 2 pi x by lambda equal to plus minus 1 in equation number 4, 5, 6, 7, 8, all these equation including displacement also, okay, not from 5, including displacement. So y is what? Our resultant displacement, and that is equation number 4. So from 4 to 8, let us substitute these values, sin equal to 0 and cos of 2 pi x by lambda equal to minus 1. Okay. Now what is equation number 4? Do you remember? Yes, this is equation number 4, and here what we have to substitute? Cos sin 2 pi x by lambda is 0, but here it is not present, but cos 2 pi x by lambda is here, and that we have to substitute plus or minus 1, and therefore this equation becomes plus minus 2a, and this sin 2 pi v t by lambda will remain as it is. See here, plus minus 2a sin 2 pi v t by lambda as it is. Again, in case of amplitude, amplitude is only amplitude capital A is equal to 2a into cos 2 pi x by lambda. If you remember equation number 5, look at the equation 5 and substitute this value, cos 2 pi x by lambda is nothing but what? Plus minus 1, and therefore this becomes only plus minus 2a, equation number 10. Now go to the equation number 6. What is equation 6? That is velocity, dy by dt. Substitute the value of cos 2 pi x by lambda, that is equal to plus minus 1, and you will get this equation, that is equation number 11, dy by dt plus minus 4 pi av by lambda cos 2 pi vt by lambda. Here we are dealing with the position changes only, don't bother about the time, that will be the next. Now next equation, substitute whatever may be these two things in acceleration equation, which is the equation number for acceleration. Yes, equation number 7, acceleration is equation number 7. Substitute these two values in equation number 7, that will give you the acceleration. Again there also no sin 2 pi x by lambda, only cos 2 pi x by lambda, and instead of that we have to substitute plus and minus 1. After substituting, you will get this equation 12 plus minus 8 pi square av square by lambda square sin 2 pi vt by lambda. And finally strain, equation number I think 8, yes, equation number 8, yes, this strain. In that sin 2 pi x by lambda, but we know that sin 2 pi x by lambda we have considered 0, and therefore that equation will be 0, strain is 0. Strain is 0, that means compression is 0, and look at from equation 9 to 12. Equation 9, displacement, resultant displacement, that is maximum, amplitude is maximum, okay, velocity is maximum, acceleration is maximum, but only one thing is minimum, and that is what? Strain. Okay, strain is 0, strain is 0. At what point strain is 0? Can you guess? Yes, at the antinode strain or compression is always 0. At the node compression is maximum, at the antinode the compression or strain is minimum. That means we can consider, if whatever we have considered these positions with these position conditions, these are the conditions valid for antinodes, or in other words we can call these positions are corresponding to antinode, because strain is 0. Strain 0, the point is antinode. Strain maximum, the point is node. That is clear. Okay. Now these particular positions are the positions of antinodes. Now whatever we have considered here, sin 2 pi x by lambda, we will exactly find what are the positions. So let us consider this, or we have already considered 2 pi x by lambda equal to 0. Okay, since sin 2 pi x by lambda equal to 0. Okay, but in general we know that sin n pi equal to 0, means sin integral or sin of integral multiple of pi is always 0, means sin 1 pi 0, sin 2 pi 0, sin n pi 0. Here we have considered m, because n we are talking about in terms for frequency. So sin m pi 0, m is any integral number. So here m is starts from 0 to n, 0 to infinity, always sin m pi equal to 0. So sin 2 pi x by lambda is 0 and sin m pi equal to 0. That means we can equate and we will directly say 2 pi x by lambda must be equal to m pi. If we equate them and take sin inverse on both sides, then finally we will get 2 pi x by lambda equal to m pi. From this just rearrange and find the x value. So x will be here x will be m pi by 2, x will be m pi by 2. Okay, pi will get cancelled here, yes, little bit mistake here pi and this pi will get cancelled, actually it is not pi, it is lambda. Okay, yes, this is not, one second, this is not a pi, this is lambda. So what we get, x is equal to m lambda by 2, m lambda by 2, because this pi on both side will get cancelled, and what is x, x is equal to m lambda by 2. Okay, now m lambda by 2, substitute the value of m, substitute the value of m. If we substitute m is equal to 0, it will be 0. If we substitute m is equal to 1, then lambda by 2. If we substitute m is equal to 2, then 2 will get cancelled and lambda, and so on. So what we get, 0 comma lambda by 2 comma lambda comma 3 lambda by 2 comma 2 lambda, and so on. So it means that these x values are what, x values are the positions of what, nodes, because these conditions are corresponding to what, node. We have seen this, antinode, because the strain is 0, the strain is 0, and therefore these conditions are valid for antinode, and this x value will give you what exactly the position of antinode. So at 0 we have antinode, at lambda by 2 we have antinode, at lambda again we have next antinode, at 3 lambda by 2 we have next antinode, and so on. Okay, right, make this correction, this is lambda, because pi get cancelled. Right, now see what we get is x is equal to this. So these are the exact positions of antinodes. Why antinodes? Because we got here in the previous slide, strain is 0, and whenever the strain is 0, compression is 0, those points must be antinodes. So these are the positions of antinodes, and the antinodes are equidistant. Now let us take this difference between any two successive these values, lambda by 2 minus 0, it is lambda by 2, lambda minus lambda by 2, it will be 0, 3 lambda by 2 minus lambda, again lambda, sorry, not 0, 3 lambda minus lambda by 2, it is lambda by 2, 3 lambda by 2 minus lambda, again lambda by 2. If we do for the next antinode position also, always the separation between any two antinode we are getting the mathematically lambda by 2, and at x equal to 0, the position of the interface is an antinode, it is also antinode. What is x equal to 0? Means that end of that organ pipe, and in the very first diagram only we have showed their antinode. So I told you there, not only we are showing in the diagram, we will prove mathematically, yes, at that point antinode is there. So antinode will be at that point, and the free end of the open end organ pipe corresponding to antinode. That was the statement I have made at the beginning only, but mathematically we have proved right now the free end or open end of an organ pipe corresponds to an antinode, and the antinodes are separated from each other by the distance lambda by 2. That means the distance between any two successive antinodes is always lambda by 2. Now this is first antinode at this point, this is second antinode, third, fourth, and so on. So if we take the difference between any two successive antinode separation, that will be always lambda by 2. So these are what the positions or the positions changes when we talk about what the conditions we have taken, these conditions, sin 2 pi x by lambda equal to 0 and cos 2 pi x by lambda is equal to plus minus 1. First condition. Now second case we will consider the positions where reverse. Now consider sin 2 pi x by lambda is maximum. Now we have considered in first case it was minimum, that is 0. So here maximum is plus minus 1, and cos 2 pi x by lambda is minimum, that means it is 0. Again substitute these values in from equation 4, 5, 6, 7, 8. Now you might got the idea how to substitute that. Here I am not wasting much time. So equation 4 is for the displacement. If we substitute there cos 2 pi x by lambda, so already we got there cos 2 pi x lambda, therefore displacement is 0. If we go to the amplitude, amplitude contains 2a cos 2 pi x by lambda, but here 2 pi x by lambda cos is always again 0, so amplitude will be 0. If we go to the velocity, again there we have cos 2 pi x by lambda, so velocity will be 0. Acceleration is also 0, and only the strain is having maximum value. All remaining factors, 4 factors, that is velocity, amplitude, displacement, acceleration, all 4 are 0, but only one thing is maximum, that is strain or compression. So already we told that whenever the strain is maximum, Whenever strain is maximum, that point is a node point. Whenever strain is minimum, that point was antinode, we have shown already. But when the strain is maximum, that means at the node the strain is maximum, and where we got strain is maximum with respect to these positions, with respect to these conditions we got strain maximum. That means these positions are corresponds to nodal point, or these positions are corresponds to the nodes. Okay, right. Now again we will find where exactly the node is situated. So this we will take the help of this, or we can take the help of this, cos of 2 pi x by lambda is equal to 0, or we can use any one. So here we will use that, since already we have used in case of the first condition sin 2 pi x by lambda equal to 0. So similarly sin of m pi is 0. So here we will use cos 2 pi x by lambda equal to 0, since here we have considered for this particular case cos 2 pi x by lambda is 0. So generally cos of odd multiple of pi by 2 is always 0. Cos of odd multiple of pi by 2 is always 0, means cos 1 pi means cos pi by 2, cos 3 pi by 2, cos 5 pi by 2, all are 0. So in general we can write 2m plus 1 will always give you odd number when m starts from 0 to infinity. Okay. So this cos of 2 pi x by lambda is 0, and cos of 2m plus 1 lambda by 2 is 0. Now from equating both the equations and taking the cos inverse, we will get this 2 pi x by lambda is equal to 2m plus 1 pi by 2. Again here pi and pi will get cancelled. Okay. But what we want, x is what, the position, it is the position of whether it is node or antinode. Now we are dealing with the node, because we found that the strain is maximum, so that positions are corresponding to node. So we want to find x, bring this lambda to that side. So 2m plus 1, and these 2 from numerator goes to denominator, already 2 was there in the denominator. So 2 into 2 4. So we got x is equal to 2m plus 1 lambda divided by 4. Okay. So these positions are corresponding to the node. Now let us substitute the value of m. We have m which is varying from 0 to infinite. So 0, if we substitute m is equal to 0, then what we get? Yes, 0, 2 into 0, it will be lambda by 4. If we substitute m is equal to 1, then 3 lambda by 4. If we substitute m is equal to 2, 5 lambda by 4, 7 lambda by 4, 9 lambda by 4, and so on. So these are the positions of your nodes when we talk about the pipe which is open at both the ends. So these are what the positions of nodal points. Now from that what we can conclude, thus the nodes are also equidistant by the distance lambda by 2. How this is, how can we say? Yes, let us take the difference between these two. 3 lambda by 4 minus lambda by 4, 3 denominator is same 4. So 3 minus 1 it is 2, 2 lambda by 4, that means 2 2s are 4. So again this difference you will get lambda by 2. If we talk about this difference, it will be lambda by 2. If we go to the next, 7 lambda by 4 minus 5 lambda by 4, again lambda by 2. So here also we can say the two nodes or two consecutive nodes or two successive nodes are also separated by the distance lambda by 2. The same was true for the antinodes also. We have seen two antinodes, successive antinodes are separated by the distance lambda by 2, and here it is valid for the nodes also. And it is clear that between two antinodes there is a node and vice versa. Yes, after a node there is an antinode, then node, then antinode. That means we can say between any two nodes there is an antinode, or vice versa, between any two antinodes there is a node, and the distance between any two successive node or antinode is always lambda by 2. And if we talk about the distance between one node and consecutive antinode, one node and consecutive antinode, it is lambda by 4. Distance between any or between node and consecutive antinode is lambda by 4. Between any two node or antinode it is lambda by 2, but one node and next antinode it will be lambda by 4. So this what we have seen, the changes with respect to position and two conditions, right? Once we have taken sin maximum, cos minimum, and reverse in the second case cos maximum and sin minimum. So these are what the two different changes with respect to position, and from that we concluded where the node is situated, where the antinode is situated, what is the difference between them, and what is the distance between one node and other successive antinode. So in this particular video we will stop here. Remaining thing is what we have to do this same, we have to continue the same article in the next video, but there the changes with respect to time, because we know that those 4 equations, those 5 equations not only changes with the position, they depends upon time also. So we will see in the next video what are the changes with respect to time, right? So if we have any problem regarding this video, you can post in the comment box, and remaining things we will see in the next video. Thank you.